have more people soon. So how many of you guys have like done any kind of programming at all? Okay. What have you done?
I've done Python, Java, just making in high school I made just like some games, and I haven't done that. I've done like a little bit of data analysis stuff, but I'm learning C right now in a class, and I've done MATLAB for a class as well, but I don't have that much experience with like embedded stuff.
Mm-hmm. Okay. What about you, Brew?
I did like some Arduino stuff in
Okay.
high school also. Also Python. I made like a Morse code game. That was also in high school. So I'm a bit rusty, but that's experience.
Get it?
All right. Nice.
Rusty.
You guys, what have you done? I know you've Elon, but I don't know about you, John, Michael, and Aiden.
I mean, I did like Java, and like we coded our robots in high school in Java. Did like the website stuff like HTML, CSS, JavaScript. I think I started that in like right before high school, then did that somewhat throughout high school. Like most of the hackathons were online, so a lot of the projects that I ended up doing were just like websites and stuff, or like web based. I learned Python. It's usually just like simple programs or just like automated stuff. What else? Outside of that, it was mainly just like learning like the syntax of a lot of random different languages. I touched C++ for a while because I wanted to get into like cross-platform development, but then I didn't really. I just got distracted, probably with something else, like a whole different hobby probably. And then like minimally like C# when I got into game development for a while. Then I got distracted by another hobby again. Yeah, I think that's it.
Yeah, I've done mostly Python and C. We did C++ for robots and Vex in high school. And I've just done most of my little projects with Python. Just like random simulations and stuff.
What about you, Elon?
I've started with Java, but really didn't do any projects in Java, apart from like studying for AP, and then C++, Python. Tried to use C and C++ the most, Python for prototyping things. Mostly do robotic simulations, those kinds of things. Embedded a little bit.
Can you remind me your name?
Amon.
Amon. Okay. The question I asked was if you have any kind of programming experience at all.
I started off with Java because of the APCSA, so I had a little bit of Java.
Yeah.
Then I moved off Python.
Okay.
I say I'm decent with Python, but I guess there's a lot more for me to learn. I guess like right now I'm just trying to like learn more Python libraries and like how to use them and stuff. So I started working on a chat bot type of thing with my friends. So what we're trying to do is like web scraping data from because Congress have to like be public with their stock trades. So what we're doing is we're web scraping all that data, basically organizing all that data and analyzing the trends in the data, and from that, our program would like make prediction of what best trades you could make based on that data.
Oh, that's a super cool idea.
Are you in the Quant Club?
What?
Are you in the Quant Club?
No.
Oh.
Yeah, just leave it wherever. While you're like getting ready, I have a question for you. Do you have any kind of programming experience?
A little bit, yeah.
Okay.
In Python, a little bit in Java, and yeah.
Okay, cool. All right, I'm just asking because this presentation could go very differently just depending on what kind of experience you guys have. I want to make sure that it's something that you guys can understand. So, thankfully, from what I've heard so far, I think we're going to be okay with this one. Okay, so kind of the goal with this presentation is to talk about something you guys may have not heard of before. And the idea I kind of talked about during our first meeting is to kind of like challenge you guys a bit and do something out of the ordinary in terms of a workshop. You know, there's a billion like Python workshops, a billion like AI workshops, but this is a little bit more niche and something you really don't hear about until later on. So kind of my goal for you guys is if you guys can understand like what this field is as a whole and kind of like some of the main issues that there are, as well as towards the end, I'm gonna do like a live like coding session with you guys, so like you could pull out your laptops and like follow along. We also can skip that if it's like running long and you guys just want to build stuff. So that's kind of the plan. Anyway, so all right, systems programming. Everything is trying to kill you, and how to stop it. Oh, be on.
What? Are you pointing towards that?
No, it's not working.
Did you turn it off?
Oh, maybe I did.
Yeah, no, it's on.
Oh wait, it's actually my fault. All right, try that. Okay. Okay, so this outline is very vague, but like I said, expectations, it's meant to be challenging, so you can stop me and ask questions. So I kind of got inspired to make this workshop because I was having a really bad day writing some C++ code, and I was like, I'm so sick of this crap, like I want to use Rust, which is my favorite language. So C++, as a noob, I still consider myself a noob at C++. It's like going into the jungle and everything is trying to kill you, even the cute animals that look innocent. So yeah, let me just roast some programming languages real quick. So this is pretty much what it's like coding in C. You're like working like right next to like a bunch of explosives like all the time. This is Python. You know, you're basically like
Just grab a chair.
like walking in a giant suit, just super bogged down and slow. You're also like bubble wrapped essentially. You're not really dealing with any of the hardware. Yeah, this is your average Rust enjoyer, not biased. All right, so yeah, let's talk about the position you guys might be in. So you just got out of CSE 1010. You're so excited to start getting more into programming, and you sort of just feel a longing for something more. Maybe it's speed. Maybe you want to feel powerful. Or maybe you just like to suffer. Whatever it is, you decide to take a chance and try something new. You know, like, look at that logo. It's a little C. It's so innocuous and innocent. What could go wrong? So you like fire up Notepad++, and you write a little program. So in theory, maybe this could blink an LED, but what this actually would do live, this would be like a live reconstruction. Yeah, so basically, things can go wrong when you code in C. It's not going to be an explosion, but you should be a little bit scared when you code in C or another language like that. All right, so let me actually get to the point. So what is systems programming? So there's a difference between application programming and systems programming, which you're probably more familiar with application programming. So application programming is sort of like your classic, you know, making like a website or like a mobile app, a Python program. It could be like Microsoft Word or TikTok, you know, the things you normally hear about. But then systems programming is a really, really broad field. It's kind of hard to define. It can be anything from like the smallest devices you interact with to like the most powerful devices that exist in terms of like computing power. So, you know, there's tons of like computer chips like put onto like rockets, space shuttles, robots and drones. Additionally, that's more on the smaller side of the spectrum. You know, if you're, let's say, building a medical device, you're not going to attach a gaming PC to like your heart monitor, right? That doesn't really make a lot of sense. So some other instances of systems programming, like, could be writing an operating system or writing a game engine. So that category is sort of like other people are using your code to write their code. So it's like, if your game engine is slow, your game is going to be slow. And same if your operating is slow, any other code you write on top of your operating system is going to be slow. So what I'm trying to get at is you need to really optimize when it comes to systems programming, because other people might be trying to build off of what you have created, or additionally, you might just be working with very little resources. So literally, like, you could be programming on a literal potato, like, and to give you a sense of like the scale of like how cheap it could possibly get with a computer, like if you look up on DigiKey, which is a website to like buy chips and stuff, you can literally buy a programmable computer for 21 cents. You're not going to be doing anything like serious with 21 cents. You can make it like turn a light on and off, or something simple, but right. So if you're not careful with your systems programming, bad things can happen. So I'm going to briefly talk about memory management. Hopefully this is something that you guys have at least heard of, based on your prior classes, but also I'm not assuming any knowledge. So this will be a review for you guys, hopefully. Okay, so memory management. It's sort of like, you can think of it as, memory is kind of where the computer stores variables and information inside the computer. And so the location in which the information is stored at can sort of be visualized as a house. So a house has a certain amount of space in it. It can fit, a limited amount of stuff in it. It can also have a specific address. So, if I were to tell you my address, you'd be able to directly identify my house. So, to sort of talk about how Python would create a new variable, it basically asks the operating system, hey, I want to make a new variable. Can you find some space for me? So for instance, if I have an array and I decide to store these 3 characters, Python would be like, hey, give me 3 houses worth of stuff so I can put these characters in it. So every time Python makes a new variable, it has to ask the operating system. Now, this may not seem that big of a deal at first, but what you might not realize is that every time Python is asking, the location of the house or the memory could be anywhere on the computer. So it could be, if you ask for one variable, maybe it's on street A, but then you ask to make enough space for a second variable, and it could be on street Z. So there's no guarantee that they're going to be close together. And the reason why you want to do something like have it close together is, computers can be sort of thought of as working as like a mailman. If the houses that you're delivering packages to are close together, then you can very quickly, just bang, 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 deliver all the packages. But if those same packages are literally spread across the world, it's going to take forever. So an alternative is basically you could look at the code that you've written ahead of time and be like, hey, wait a second, I know for sure that I'm never going to need more than 100 houses worth of space. And so you could basically ask the operating system up front, please give me 100 houses worth of space. And the operating system will find you 100 houses in a row. And so because they're in a row, you're able to very efficiently go from house to house. So this kind of gets into the difference between an interpreted language and a compiled language. So an interpreted language basically reads your file, and like I said earlier before, it sort of looks at it one line at a time and request stuff as it sees the next line. So this would be like buying houses as you need them, versus a compiled language, it sort of looks at, okay, I won't need more than 100 houses, let me buy all this stuff up front. So that's kind of the way you can look at it. All right, so the next part of this presentation, it's sort of going to be talking about common issues when it comes to memory management. So now that we've sort of talked about how things are laid out in memory, let's talk about some things that could go wrong. But this program actually does not have any specific, there's nothing specifically wrong with it. I actually want to hear from one of you guys what you think is wrong in terms of, does this smell bad? Does this code have any issues with it?
Maybe it's the last line, like where it's like string, like instead of an integer.
Mm-hmm. So, okay, what happens if I put in a string inside the, wait, this has a laser pointer, right? Well, I guess that won't help. So, what happens if I plug in a string and a number into that same function?
Wouldn't it multiply the length of the string by the number?
Yes, so, go on. What would the output be exactly in the two cases?
First one would be 10, the second one would be 13.
Not quite.
The second one would just run hello, 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 hello 3 times.
Mm-hmm.
Because Python isn't hard to detect, so like, you can put any type of variable through the function. Yes,
Exactly. That's, like I said, this technically works in Python, but if you were to do this in any other language, it would not work. It is, in my opinion, that dynamic typing causes a lot of bugs because you can sort of put anything into any variable, and other times it'll fail immediately. But at other instances like this one, technically it'll still work for a little while before it fails. So there's no good way to know ahead of time if your code is going to work if it's dynamically typed. So to sort of elaborate on this a little bit more, a statically typed language means the variables, each of them always have one specific type. Do you guys know what I mean when I say a type? Okay, so a type is like, think of it as, it's a really abstract concept, but think of it as like a category of something.
Okay.
So a category like, numbers or letters or shapes, you could come up with your own category and sort of, depending on what you need. Part of the programming process is basically creating your own types / categories. So, for instance, maybe I could create a variable that holds a mayonnaise type. Okay, so mayonnaise is just it could be an abstract thing. Additionally, I might make another variable that is of type instrument. So if I try to put that mayonnaise variable inside the instrument variable, it won't work because obviously mayonnaise is not an instrument. You guys kind of get what I'm trying to say? So that's what statically typed kind of helps you prevent. It prevents you from making like a silly mistake like that. Okay, so now we get into the meat and potatoes of the presentation. So memory safety is a really, really big problem in computer science. Like in the very beginning, I had that whole table of different, I'm just going to show it briefly since some of you guys came in late. So this is kind of on the right-hand side is basically everything that falls under the category of systems programming. And a lot of things fall under systems programming. Very important, like they could be life critical. They also affect billions of people on Earth. Every single person here uses a browser and an operating system. both of those are systems programming code bases. And with this particular thing of memory safety, if you don't handle the way you manage your memory properly, things can go really, really wrong. People can hack into your system. They can. People have actually died because of medical devices that had these kind of issues. And the thing is with memory safety issues is they're kind of hard. They're really, really hard to spot. You could have like 20 years of experience, but maybe you just have an off day and you just make a mistake that nobody notices until it's too late. That's kind of like the lead up. Okay, what is memory safety? So it's hard to pinpoint exactly what it is, but it's a lot easier to talk about what unsafe memory management is. So I made pictures for all of these. Typically people would show like code, but again, I wasn't sure who would be attending. The header is a little bit cut off, but this is supposed to say null pointer dereference. So what that means, all right, going back to the houses. Imagine I am a landlord and I have a bunch of houses under my control, I guess. And I say, okay, I'm gonna just assume that somebody lives in this house that I own. Like I talked to them maybe a while ago, they're probably still there. But then I go and check back like 2 weeks later, and then the entire house turns out is just completely, disintegrated. So the way that correlates in programming would be you just assuming that there's always a value in a variable when that may not be the case. Sometimes there could be the null or none variable. So this can happen pretty often if you're not careful. Another one is a subfault. Let's say I'm the landlord, Alice, and I want to just take a quick look at Bob's house. All right, Bob's house is obviously not mine, and if I were to actually start going inside his house and doing stuff, he's going to call the cops on me, and the cops in this case would be the operating system. Obviously, or maybe not obviously, you wouldn't want some random Python program running on your computer to be able to see what your bank account Chrome tab is like looking at. Like it shouldn't be able to see what your account balance is or what your account number is. So if you were able to look across other people's houses, you could instantly just break into everything. So the operating system kind of just stops you. You're not allowed to do that. Does this make sense so far? Do you have a question?
No, I was just gonna say
Oh.
I'm having that problem right now in one of my classes, CSC 3100.
C? Okay.
Nice.
Yeah.
We can talk about it later if you need help. All right, this one's a little bit more complicated. I'll try my best to explain it. So, hypothetically, by the way, this is called a race condition. So, let's say I make a game where I have a mailman. So, a mailman picks up mail if it sees some in a mailbox. Additionally, it drops off any mail that it has into the mailbox. So, let's say I have a whole bunch of mail people dropping off packages everywhere, but none of them really can talk to each other. They're sort of just like, they have a list of everywhere they need to go, but they don't know who's already been visited. Does this sort of make sense so far? Okay. So what can happen is, I'm gonna slightly adjust this slide because I want to have you guys see the full picture.
Why is it not showing up? Is it a formatting thing or it's too big for the...
It's just a slight formatting issue. that's a little bit better. So, okay, let's say this mailman has nothing to deliver, okay? They're just going to see if there's any mail to pick up, all right? But it turns out that another mailman had just delivered a gaming PC. Now, according to this game, this mailman would go over to this mail and be like, oh, there's a package here. I gotta deliver it for the person at the house. And then they end up stealing your gaming PC. So what this kind of demonstrates is when there's multiple, I guess, parties trying to access the same address or mailbox, there can be unintended things happening because they aren't really talking to each other or coordinating. You know, ideally, you would coordinate and make sure that your gaming PC isn't picked up by the mail people. Does this make sense? It's okay if it doesn't. Right. And then a memory leak, and this one's cut off again too, but I think this one's easy to explain. So this is like, let's say I have a house, and then I just let it sit there for the next 20 years. That's the closest explanation I have to a memory leak, where basically, you know, the operating system, aka the government, wants to take back whatever space you're not using. But since you still technically own the house, you know, they're not allowed to take it back from you. But, you know, because you just let it sit there, it's just taking up space, wasting away. Is this clear? All right. Great. All right, so at this point, it's like, okay, all these problems can happen when it comes to programming in C or other systems programming languages. And obviously, people have worked really, really hard to try to address these issues. There's definitely practices to avoid these kinds of problems, but again, one careless mistake and bad things can happen. So, okay, question for you guys. When was the last time your code worked on the first try? Anyone want to share? Nobody?
Hello world.
I don't think my hello worlds even work first try.
All right.
Yeah, it never does.
Okay, how many tries does it take?
Depending on like how much of a hurry you're in, the more hurried you are, the longer it takes. But if you're like kind of calm, relaxed, checking each line, it's generally quicker. But you can never tell because you can just make minor mistakes.
I want a number.
Oh man. Okay, I would say 4.
4. Okay, 4.
If it's the smallest script, no, I'm just kidding. It
Okay.
could be anything.
Anyone else want to share? So I want to show a few minutes out of this talk. I shared this in the Discord earlier because this literally just blew my mind. Hopefully you guys can sort of understand the, how do I say it, the what these people have managed to achieve is literally incredible. Okay, so this is like a couple minutes out of a conference for a programming language.
Thank you so much for that introduction. Thanks to the conference organizers, all the other speakers, all of you guys for being here. This has been a phenomenal few days. Really, really special time. But I can't spend too much time talking about that because we got a lot to get through, so let's go ahead and jump in. So here's a quote that was definitely actually said. You can't prove that I'm wrong. So here's some things about me. If you want to take a photo of this slide, you're welcome. I'm not going to spend too much time on it. So what is this talk about? I'm going to bury the lead just a little bit here, and we'll talk about it in a few slides. But first I want to talk about NetStack 3. So NetStack 3 is Fuchsia's next generation pure Rust networking stack, and it aims to replace NetStack 2, which is written in Go. So I started NetStack 3 about 6 years ago, led its development for the first 4 years, and then for the past 2 years it's been led by a different team. Now, I haven't been on the project for 2 years, so obviously this is beyond me now. It's a huge team effort. I'm going to be bragging a lot about those folks. There are some really good engineers who work on that now. Now, writing a networking stack is a very serious undertaking. It's responsible for almost all networking traffic in the operating system. It implements dozens of protocols, each of which is specified across hundreds of pages of documentation. And it is the first line of defense for any attacker who's trying to get into the system, other than the ones who are sitting physically in front of the device. It's also just big. As I said a second ago, it's taken us 6 years to get to this point. There have been, plus or minus 10 developers that whole time. It's split across 63 different crates that span a total of 192,000 lines of code. That's more code than the top 10 crates on crates.io combined. So over the past year, the team has finally been getting ready to actually launch. And those of you with networking backgrounds will know that you don't just deploy networking code into production, right? Networking code is famously difficult to test. And so you have to assume that despite all of your best efforts, your code is just riddled with bugs. And so for a project of this scale, deploying an entirely new ground-up rewrite of a networking stack, you would expect to dog food in the field for months or maybe even years before you actually ship to real users. And in that time, you would expect to uncover tens or hundreds of bugs that you hadn't seen during development. And only once you'd burned all of those down and seen relatively stable behavior for a while, then finally you're willing to actually deploy to real users. So let's talk about what that process has looked like for NetStack 3. So for the past 11 months, the team has been ramping up a dogfooding program. It's at peak been about 60 devices running nearly 24/7 in developers' homes. And again, if this were any other NetStack, we'd have expected to uncover a giant mountain of bugs in that time. So over the past year, how many bugs did the NetStack 3 team uncover in the field? 3.